Dear student, in this session, we will discuss the subtopic 3.3 InterProcess Communication, that is IPC, from unit number 3, Process Management. The course outcome for this is you will able to execute the process commands for performing the process management operation, and the learning outcome is you will able to explain the function carried out in the given process state. In the previous sessions, we discussed in 3.1 the process state and process control flow. In 3.2, we discussed the process scheduling, and now in this session, we will discuss the inter-process communication, that is the IPC model. The two models are available, the shared memory and the message passing. Now, let us discuss the inter-process communication. We all know that the processes that are available within the system may be the independent processes or the cooperating processes. Independent processes are the processes which are executed independently. That means it cannot be affected or be affected by the other process executing in the system. That means the processes does not share their data with any other process, they independently execute. Another category of processes is called as cooperating processes. The processes may be affected or affect by other processes, including the sharing of data. That means in this situation, the processes shares their data with other processes. Now, there are several reasons for providing an environment that allow the processes to cooperate. So, some of the reasons are, the first is information sharing. Several users may be interested in the same piece of information. Then, in such a situation, we must provide an environment to allow concurrent access to such information so that the information will be used by different users. Another reason is computation speed. As we want a particular task to run faster, what we used to do is we used to break the task into multiple subtasks, each of which will be executed in parallel with the other. So with this, the systems speed up with the multiple processing. The third reason is modularity. We may want to construct the system in the modular fashion. It means dividing the system function into separate processes or thread and executing them separately. The fourth reason is convenience. Now, even an individual user may work on many tasks at the same time. User may be try to execute the process or the work like editing. He may want to do printing, he may want to do compilation, and all to do this in parallel. So there will be a convenience for the user to do more than one task at the same time with the help of cooperating processes. So to do all this, we require the cooperating processes. So that is nothing but the inter-process communication mechanism. So what is it? It is nothing but exchange of data and information among the different processes, and that we can do with the help of the model called as IPC model. the models available are the shared memory. One of the type is shared memory and another one is the message passing. So this is the diagrammatic representation of the shared memory and the message passing. So here we can see that in the shared memory we have the shared memory which is attached with any one of the process, and that particular memory is used by other processes that are available in the memory. So from this diagram we can see that there is not at all any intervention of the kernel in case of the shared memory. So let us see what exactly the shared memory is. It is nothing but an area of memory which is shared among the processes that wish to communicate. So whatever the processes that want to communicate with each other, the area of a small area, we used to call it as a shared memory area, will be shared by all those processes. So this particular region, that is the shared memory region, it is reside in the address space of the process, creating the shared memory segment. And other processes that wish to communicate or use that particular data will be communicate using this shared memory segment that must attach to their address space. Then they can exchange the information simply by reading or writing the data into the shared memory. So the communication is under the control of the user processes and not the operating system. So this is very important. Whatever the communication that takes place between process A and process B, that will be under the control of user process and not the kernel. Shared memory allow maximum speed. So this is one of the advantage we can say related to shared memory and convenience of communication. Why? Because it can be done at the memory shared within the computer. It is faster when we compare it with the another model, that is the message passing. One of the issue related to shared memory it is to provide the mechanism that will allow the user processes to synchronize their action when they access the shared memory. So synchronization is one of the issue that is related to the shared memory. Now let us discuss one problem related to shared memory, that is the producer consumer problem. This is the example related to the shared memory. So paradigm for cooperating process is the producer process, it produces the information, the consumer process, it consumes the information. So whatever the information that the producer process, it is produces by the process, and we used to call it as a producer. And some sort of process it want to consume or use that particular information, we used to call it as a consumer process. So two example we will discuss over here. A compiler may produce the assembly code which is consumed or used by the assembler. The assembler may produce the object module which may be used or consumed by the loader. Another example is the client server paradigm. A web server, it produces the HTML pages or the files or the images, whatever we can say. And these will be consumed by the client web browser requesting the resources. So these are the examples related to the producer consumer problem. Now one solution to the producer consumer problem is it uses the shared memory. So when someone is producing the information and another one is consuming, so some sort of memory is required, and that is used by as a shared memory. So to allow the producer and the consumer to run concurrently, we need a buffer of item. Okay. So this is buffer of item which will be filled by the producer and which will be emptied by the consumer, because whatever the data we want to produce, that data we will put somewhere. That is what we call it as a buffer, and that particular data will be consumed, so that or emptied by the consumer. So for this purpose we require the buffer, or we called it as a memory. So this buffer will reside in memory that is by shared by producer and consumer process. So this buffer produces one item while the consumer is consuming the other item. So this is the process, or we can say cycle, that is continuously going on, and they must be in synchronized. Okay. So two types of buffers can be used by this system. One is called as the bounded buffer and another called as a unbounded buffer. So the unbounded buffer, it places no limit on the size of the buffer. The consumer may have to wait for new item, but the producer can always put new item into it because it is unbounded. So size limit is not there. Another is the bounded buffer, which we assume that the size of buffer is fixed. So the bounded buffer, in this case, the consumer must wait if the buffer is empty and the producer must wait if the buffer is full. So this is all about the two types of buffer that are used in the shared memory, unbounded buffer and the bounded buffer. In next subpart, we will discuss the message passing model. Thank you.